This is Algebra 1, Lesson 48, Analyzing Measures of Central Tendency. So if I said measures of central tendency, how many of you know what I'm talking about? Nobody's hands went up. All right, but if I say mean, median, and mode, how many of you know what I'm talking about? Everybody does. Okay, great. So just because we don't understand measures of central tendency doesn't mean that we don't know what we're going to be doing with this lesson. So we're talking about a lot of different things, and this will carry over into Algebra 2, it'll carry into Algebra 3, but we'll look at things that take this and go a little bit further as we advance. So measures of central tendency are values that describe the center of a data set. Okay, so we're looking at data then. Where might we look at data? What kinds of things look at data? A chart? Okay, yeah, charts look at data. Where might we collect data from, though, or what kinds of data could we collect? What do you think? Where might we want to collect data from? What types of things could we do to collect data? You guys know this stuff, you're just not thinking about it. Take numbers from, yeah, but you're talking about things that already exist, right? Where might we want to actually collect data? Experiments, sure. Where else in the real world do we see data? Some of you guys I know are really, really into this, but you're not picking up on it. There's stuff that you guys are interested in that are all about data. What's that? Farming, sure. What kinds of data do you look at in farming? Test samples for crops. If you're measuring, let's say, humidity in corn, right? You got a tester for that, right? And so you could, I'm guessing that you put corn or beans in different grain bins, and so you test batches, right? And so you test those batches, and you could tally up those numbers. You might see how efficient one grain bin is over another grain bin, something to that effect, or one crop, one field versus another field, or even one seed versus another seed. If you plant different types of seed, we could do that, right? And so a farmer might test different seed plots in order to determine maybe what kind of seed he wants to buy next year based upon what his yield turned out to, right? So farming is filled with data, right? Maybe even cattle. What kind of data would you collect on cattle? What's the most important thing when it comes to selling steers? Their weight, right? And what might I look at? What might be the cause for a certain batch of steers weighing more than another batch of steers? Time in the pasture, or the way they're fed, or the type of feed that they're fed, right? So you might look at those things and make decisions and change things, right? The one I was looking for, though, was sports. Do they collect data in sports? What's maybe the most sport data? What sport collects the most data, do you think? Baseball. Baseball has granted, football has tackles, interceptions, receiving yards, running yards, rushing yards, all that kind of stuff. But you ever watch a baseball game on TV, and they have data collected on everything? And they'll talk about, this guy hits this many pitches off left-handed pitchers in home games played on weekdays, right? They have ridiculous data, right? Because they want to know. Okay? In fact, did you ever watch the Moneyball? Right? Moneyball is based upon picking players based upon just getting on base, right? That's the whole movie, is finding the cheapest guy that could get on base, right? So does data play an important part in real life? Yeah. Any of you want to own your own business someday? Yeah. What kind of data do you think you might collect? Salary costs, insurance costs. Maybe, do you want to create your own product and sell your own product, or do you just want to own your own business and sell other people's products?
Probably
Sell everything. Sell your own stuff, sell other people's stuff. What kind of data are you going to look at on a regular basis? How about sales, right? You know, what kind of stuff sold? Because listen, you can have two of the exact same product, right? But one sells and one doesn't sell. Well, which one are you going to sell? The one that sells, right? Right? There's 1,000 different brands of what kind of stuff do you want to it's like a sports store, Nike, Under Armour, Adidas, Asics, you know, all that kind of stuff, right? But you want to carry the stuff in your store that one is going to make the most money, right? Make you the most money, not cost you so much. All right, so we can spend a lot of time talking about all that, but I just want you to understand at the beginning that this is important and it has application. Does that make sense? Okay. All right, so the mean, hopefully we understand what the mean is. What is the mean? Can somebody tell me? And not just look at it, but understand, tell me, explain to me what mean is. And then what? Not just like how many numbers there are, but we're going to add up all the numbers and divide by exactly how many numbers there are, right? And that's going to give me, what's another word for mean? The average, okay? All right, the average. All right, then we have the median. Can anybody explain without looking and reading what the median is? All right, Blayton, give it to me again. It's not just like the middle number, it is the middle, right? Sometimes we use the word like too much. But how can I just have a random set of data all scattered up and scrambled and collect and find the median, right? I just line them up and find the one in the middle. Is there anything I have to do with the data before I can find the middle number? Has to be in order. Okay, what kind of order? Alphabetical order? Least to greatest. Okay, least to greatest. What if as I'm looking through there and I'm counting, from either side all the way through, and I find out that there is no middle number, right? There's two numbers there in the middle. What do I do with those? I average those two numbers, right? I add them up and then what? Divide by 2 because there's only two of them. Okay, good. What about the mode? What is the mode? Somebody who's not Blayton's answering a lot of these. Tiffany? Is it okay? So the number that occurs the most, is it possible that more than one number could occur the most, right? That two numbers could tie. What if there's only one of every number? Is there a mode? No. Okay. There may not be a mode at all, or there might be more than one mode. Okay. All right. Then we have a range of a set of data. Does anybody know what the range of the set of data is? Already familiar with that? I've got two people that are familiar with it. Okay, Caden, tell me about the range of a set of data. I subtract the biggest number from the smallest number. I subtract the smallest number in the data set from the largest number in the data set, right? That's going to give me the range of values that I'm going to look at, okay? All right, and that's essentially what it says up there. And then we have an outlier. How many of you are familiar with an outlier, what that is? Okay. Reagan, tell me what an outlier is. All right, so it's a number that is either a lot greater or a lot less than what? Than the rest of the data. So if we look and we see that most of the data is all nice and clumped up, fairly close together, and then we have this one number that's way off to one side, either small or large, that would be my outlier. Okay, what is an outlier, how's it going to affect the data? What could it do in terms of measures of central tendency? Not necessarily. It won't necessarily make the numbers less accurate, but let's talk about measures of central tendency. Let's go back a page. Is it necessarily going to change the mean? Would it change the average? Okay, so if it was a whole lot greater, right, it's greater than all my other data, what is it going to do to the average? It's going to raise it. What if it's way small? All right, think of test scores in the class. If I add everybody's up and somebody got a 2%, right, but everybody else scored like 60, 70, 80, 90, right, it's going to bring the average for the class down. Or if everybody scored 20, 60, 30, and somebody else scored 100%, right, it's going to bring the average up, okay? So it can raise or lower the mean. Is it going to change the middle number, really? No, because you're not talking about the size of the number, you're just talking about the position of the number. All right, what about the mode? Well, only if there's more than one of them, right? All right, and if there's more than one outlier, it may not even be an outlier. So it will change the average, okay? All right, so that's 48. Let's take a look at some information here. Okay. And a lot of this stuff is stuff that you guys can do math-wise. Find the mean of the values in a data set: 31, 18, 16, 25, 49, 39, 39, 39. All right, so what do I need to do with this? Add them up, and then divide by what? I'm going to divide by all of them. I'm going to divide by what? I'm going to divide by 8. Okay, then I'll add them all up and divide by 8. Okay, good. Does anybody know what that number is? 31 plus 18 plus 16 plus 25 plus 49 plus 39 plus 39. Let me show you guys something. You guys have a graphing calculator on hand? Not right now. You may want to pick one up because this is kind of cool. All right, you can use this later, especially if you're taking the ACT. Everybody look up here for a second. All right. You're going to use something in your calculator today that you might not have used before. It's called the stat button. All right, do we have our calculators on? No? Yes? All right, do you guys see the stat button there? All right, hit that stat button. All right, do we see edit calc and tests? All right, do you see on the edit side how we have the word edit? I'm going to hit edit. All right, see list 1 here? I'm going to plug in my data. 31, 18, 16, 25. After one, I'm hitting enter. 49, 49. Hopefully we get that. 39, 39, 39. So 39 once, 39 twice, 39 3 times. All right. So do we have that data in there? Yes, no? We're working on it? Okay. Now I'm going to hit stat again. Okay. Notice how it brings me back to this. I'm going to hit my arrow key to the right. I'm at calc now. Notice how the first thing up is one variable statistics. Do we find that? Okay. I'm going to hit enter. I'm going to hit enter again. You may have to hit enter several times until it goes down to calculate and hit enter if you have a newer calculator. Okay. And we have a whole bunch of information here, and later on I'll tell you what all this means. But for now, all you need to know is that the symbol for average is an X with a line over the top of it. So what is the average of that data set? What number is next to X with a line over the top? 32. Did anybody add those numbers up and divide by 8? What did you get? Okay. So do we see how our calculator can do some of these things? Yes? Okay. All right. Is that cool? Does that help us out? Okay. Might save us a little bit of time. All right. What I want you guys to do is I want you to plug in into your calculator where I showed you to plug it in and how I showed you to plug it in. I want you to plug in this information. Okay, 19, 7, 16, 2, 10, 6, and 7. Okay, so I'm going to go back in here. I'm going to hit stat again. I'm going to hit edit again. And I'm going to replace my information with 19, 7, 16. Oh, now we're coming to pick up calculators, right? Because we see that it's a lot easier than having to do all that work myself. 2, 10, 2, 10, 6, and 7. Oh, and notice how I still have another 39 left over. In order to get rid of that, because I don't want 39 in my data set, I'm going to hit delete, which is this third key over on the right at the very top. Okay. Do we have that information in our calculators yet? All right, now notice on this question, it doesn't want just the mean. What else does it want? The median, mode, and range. Okay? All right, so I'm going to hit stat. I'm going to go where? Where do I go from here to get my information? Got all that information in there. Hit stat. Now where do I go to get all the information? Does anybody remember? We all forgot. You see how this is my point that I want to make. Just because your calculator can do all the work, if you don't know how to use your calculator, can you get any of the answers that it has for you? All right. I need to go to the right to hit calc. Anybody know what to do from here? Hit enter because we want one variable statistics. Enter. All right. What is the mean? No, but what is the mean to this question? Let's round it to the nearest tenth. I got a whole bunch of numbers there, right? Is the mean 67? Is it 855? Is it 5.9? Is it 5.5? It's 7? It's what? It's 9.6. How do I know? All right, because the mean is the number next to x with the line over it, right? Okay. Now, if I want the median, right? I don't see median anywhere in here. So I'm going to hit down here. How do I get where? Hit stat again, then go over to calc, and then you have to hit that a few times. All right. So, all right. So some of you might have missed what I just did here. Okay. I got my information here, but if I want the median, I have to scroll down. Now, what this information that it's giving me here, Q1, median, Q3, min, and max, those are information I would use for a box and whisker plot. How many of you are familiar with a box and whisker plot? Everybody in here? So we recognize all that information as box and whisker plot information, right? But if you'll notice, what does MED stand for? Median, right? So what is the median of my information here? 7. All right, so median equals 7. Now, it's not going to give me my mode or my range, okay? But mode and range are really easy things to find, right? All right, so let's get out of our calculator here. All right, so we know 9.6 and 7. How do I find the mode? Okay, you said it's 7. How did you find it? Most common number. So as you went through here, you found a 7 here, you found a 7 here. Did any of the other numbers repeat at all? All right, so mode was 7. Okay? Now, range. How do we find range? Okay, what's the smallest and the biggest? 6 and 19. How about 2 and 19? All right, what do I do with those numbers? Subtract. All right, so 2 minus 19, right? And get, what, negative 17? Negative 17 is my range? Oh, no, now I got to do what? 19 minus 2 is what? All right, so my range is 17. Do you think I didn't know what to do? Or do you think I was maybe just seeing if you might make a mistake? Because sometimes we do the wrong things, right? Okay, so does that match anything that's up here? A, mean 9.6, median 7, mode 7, range 17. A is my answer. So we're familiar with this, right? Okay, have we learned anything new today? Okay. No, you didn't learn anything? You already knew how to use your calculator to find that information? Did it make your life any easier? Yeah? Can I use my calculator now to test answers? Abby, stay awake. Okay. All right. So now some of my information is going to be listed a little bit different here, but I can still put it in my list, or I can still add all the information. Can we tell me what the mode is going to be there? 41. 41 shows up more than once, so I know it's either got to be A or B, right? I can figure out my mean. Notice the A and B have the same mean, so I'm looking at my median. Granted, there's only, 5 numbers there, right? So it might actually take longer to put all that information in my calculator than it would be just to order those questions to find the median. What's the smallest number? 24, then what? All right, 27, then what? 31, then, and then 41. All right, 1, 2, 3, 4, 5. So what, 31 is the middle? All right, so what, A is my answer? Okay, that wasn't too hard, right? Okay, but if I see this question on a test, can I show my work? Are you just going to say, calculator did it? No. What do we use our calculators to do? To check and test, right? To confirm what we already did, right? Or to find out that, oh, my math is wrong, I need to go back and fix it, okay? All right, we never just say that our calculator is right, because can our calculator ever, I'm not saying that your calculator made a mistake, but can we plug the wrong numbers into our calculator? Yeah. Okay? You could go into your list and forget to delete an old number, right? And wind up with a completely different set of mean, median, and mode. Right? So we use our calculator to check, but we don't lean on that calculator because our calculator can still make a mistake if we make a mistake in the calculator. Okay? We familiar with that? Okay, so basically the rest of this keeps going on, but let's look at this real quick because it includes something that we haven't actually done yet, which is an outlier. Okay, what number is my outlier? 122. It says identify the outlier. We've done that. The outlier is much bigger or smaller? Much larger. It says then find the mean, median, with and without the outlier. Okay? So if I was plugging in my data set into my stat list, right, I would probably put 122 in last. That way I could go in and real quickly delete it, right? Get all my information and then check it again. What's it going to do to the average? Is it going to make the average bigger or smaller? It's going to make it larger. So let's just look at the two answers that have 122 as the outlier. All right, notice the mean with the outlier they say is 12. Notice the mean with the outlier on C is 27.7. Can both of them be right? No. What do we think that the outlier is going to do? Is it going to make it bigger or smaller? Bigger. So notice on A it says the mean with the outlier is 12, but the mean without the outlier is 27.7. If we take 122 out, is the mean going to get bigger? No, it's going to get smaller. So is A correct? No. So which one would I naturally look at as correct? C. Now, does that mean I'm not going to do any math to prove that? No, I'm going to do my math to prove it. Okay? But just so that we're looking through everything in here and we understand how these things work, I'm not necessarily plugging it all in. Okay? There's a lot of questions in here that you can look at, but we're not necessarily going to go through all of them. We have a couple minutes here. Do you want to look at some questions in your book? Yes or no? Okay. Somebody says yes. What question would you like to look at before we close out this morning? Your choice. Yeah? 1 or 4. Okay. All right, so you want to look at, it's, anybody else have a choice between 1 or 4? 1, okay. So looking at question 1, says 4ab squared c to the 4th minus 2a squared b cubed c squared plus 6a cubed b to the 4th c. Okay, it says find the greatest common factor. That's the largest thing that will go into all of this, or what can I factor out of it? What can I take out of 4, 2, and 6? The biggest thing I can take out is 2. Okay? What about a squared, and a cubed? A. What about b squared, b cubed, and b to the 4th? Just b? The largest thing I can take out is just b? B squared, right? I have to take out the one with the smallest exponent. B squared will go into all of them. What about c? C to the 4th, c squared, and c. Just c, right? That's it. This is your greatest common factor. That's the largest thing I can take out of all 3 of those terms. Does that make sense? Is that easier than what we were worried it might have been? Okay. All right, we'll stop right there.